All right, so I swear Matt and I didn't coordinate this, but I'm gonna kind of pick up right where he left off with the documentation piece. So again, my name's Scott, CEO and co-founder of, CEO and founder of Sublayer. And this talk is Frameworks as Pidgins and Creoles, How Humans Will Talk to AI About Software. And yes, this is actually using my prompt-based web framework that I presented up here a few months ago, Monkey's Paw. It's on fire with Sonnet 4, just like letting it loose, so get ready for some cool visuals. To start things off, like Matt was talking about, AI coding is here to stay, and it just keeps getting better. It's wild. But, the thing is that we are continuing to just use it to build a lot of the same stuff we've been building for the last 20 years. And that's been bothering me. I've been wondering why that is, and looking to see if other people have noticed it, see if other people have made predictions of why that is. And I think one of the things that I keep coming across is people bringing up the conversation and asking the question, do we still need frameworks? Do we still need libraries when AI can write all of the code? I think I have an answer to that, and so that's why I'm up here. But I think the answer comes from linguistics, which makes sense because these are large language models, and there are these concepts of Pidgins and Creoles. And so you might be asking yourself, if you're not familiar with these things, what are Pidgins? Well, Pidgins are these languages that come about when two communities that speak different languages need to find a way to communicate, like over trade routes. And these are usually simplified languages that both can kind of understand. And then a funny thing that happens with Pidgins is that over time, kids are born into those communities and learn to speak those Pidgins natively, which they get called something called a Creole, where they end up having a full grammar, a richer vocabulary, and are kind of like a real language. And this transformation happens naturally. And so I think you can kind of guess where I'm going with this next. That's very similar to the evolution of frameworks when you're working with AI. Frameworks can act as a Pidgin or a Creole when you and the AI are building an app. I was having a conversation earlier. I can't really see you back behind the pillar. But over the last few months, I haven't really even been looking at code that Claude Code or Codex has been writing. I've just been communicating with the concepts of the frameworks that I'm using. And the way that in my mind that I'm starting to think about it is if the framework, if I need to provide a lot of examples, if I need to do a lot of few-shot prompting, if I need to copy-paste docs, that's essentially a Pidgin framework. The LLM doesn't have the same concept. I need to add more. I need to rely on the in-context learning. But Creole frameworks are ones that are in the training data, and the AI kind of just knows them, and there's a natural understanding there. And some of those examples that I think a lot of us who have started playing around with these AI agents have run into are things like React and Rails. It's another way of saying, AI agents are really good at Rails because of convention over configuration. Those conventions that you can communicate with the AI about at a higher level have a lot packed into them. And that enables richer communication with the AI. Same with React. There's a lot baked into make this button a React component. Even me saying that to you, that's like our little kind of Creole here of there's a lot baked into that. And then, like similar with Tailwind and all the CSS stuff that's going on behind the scenes there. Which brings me to VSM, which Matt mentioned. You don't have to, there's a lot of writing on this slide, but I'll get into why you don't need to worry about that. But I wanted to announce here, just released today, VSM 0.2.0. It's based on this idea from cybernetics called the viable system model. And the really brief description of it is that basically you can model anything, any system as you can model anything as these 5 systems that are composed of identity, governance, coordination, intelligence, and operations. And I thought that was a very interesting model for building AI agents. And the funny thing is, nobody has really tried to build a software system like this before, so there is very little in any of the models training, any AI models training data for how to actually work with a system like this. And so I've been using this framework as an experiment to explore what that means to try to build this language together with an LLM and interact with these concepts that it doesn't really have baked into its training. And so, we'll get off this slide really quickly, sorry. The way the framework works is that there are these things called capsules that encapsulate these 5 systems. Identity defines the agent's purpose and the invariance. Governance, enforcing the safety rules and policies. Coordination manages turn-taking across the different tools. Intelligence, basically the interaction between the framework and the LLM. And then operations, which are tools, but also any of the tools can themselves be a capsule, so it's kind of infinitely recursive that way. And so what is there to learn from an architecture like this? Well, by having these named responsibilities, and I don't know, afterwards we can go over to the standard beer garden and I can talk your ear off about how that takes care of everything. But these named responsibilities give us, both me and the AI agent, a shared vocabulary. I mentioned before the capsules are recursive building blocks. Tools are first-class citizens, and trying to build this for AI collaboration from day one, which is kind of working, kind of not, but it's a fun experiment. So let's get into a live demo here of the new stuff that was just released in version 0.2. And this is, again, this is from the prompt-based web framework, so that is not an actual interface of this thing. It was hallucinated by Sonnet. But I left it in there because it looked fun. All these animations are invented by Sonnet. Anywho, so the one thing I kind of glossed over, so yeah, AI coding agents are kind of one of the first killer features that we've found for AI, for generative AI, but the other thing that's been really surprising is this return to CLI-based agents. And so that's one of the new features that was just released with VSM, is the ability to create your own CLI-based agent with whichever provider and model you'd like. And so let's do VSM new file reader. And it generates a new project for you. And it starts conveniently with a file reader tool for this demo. And so we can go ahead and do bundle exec exe file reader. And we get a prompt, and let's see what tools are available. And this one, I think it defaults to OpenAI, but you can switch to any of the models you'd like. Available tool for reading functions.read files. So tell me a joke about the contents of the readme.md file in this folder. Calls the tool read file that's baked into it. And why did the minimal VSM app start a conversation with the file? Because it wanted to read between the lines. That's pretty good. I did not tell it to do that. Turn 3. So that's a little bit of the basics. That's, one of the features was just getting started there. But like we mentioned here, we want to be able to introspect and learn about the object as it's running. And we released this new set of tools called the meta tools. And we can run bundle exec. Oh, sorry, I guess I'll actually go back there. So this is what the agent looks like. You define an identity class with some arguments, governance class, coordination class, intelligence class, monitoring, and then operations where you put the tools or subsystems. Just added a subsystem that's baked into the framework. Meta tools, we can come back and now run this and what tools are available. And list the meta tools. Obviously, it has the read file tool, and then it has tools for summarizing itself, listing the tools. Why you see this in, if you can, if you read Markdown, the bolded titles here, and explain a tool and explain roles. So as you build these systems out, it's able to introspect on the different roles, and so you can ask it, what is this capsule's particular identity? It calls the meta explain role tool, and you can start to see, there's a lot there, but tells you what the identity role does, but then also, yeah, this is, doesn't work great on the presentation, but trust me. You can do things like, what does explain the file reader tool to me, and calls the meta explain tool, explains the file reader tool. Sometimes it gives you, it actually reads the contents of the file, reads the contents of the class, and leans into a lot of the stuff that Ruby can do where it can like think about itself. I didn't get a chance to actually have it, I ran out of time getting it to make its own tools and run them locally, but it's coming. The other thing I wanted to show is that it also supports MCP, so if you have if you're building an MCP server, if you have a set of tools, if you want to build a, basically like cloud code for whatever you're doing, maybe it's for posting stuff on Twitter, just add the tools, add the MCP server, and you're good to go. Here is an example of using comes with a full set of example things here. Let's see, Ruby 09. MCP with LLM calls. You will say what tools are available. And these are all the tools that come with Claude Code's MCP server, bash, task, to-do right, etc. Let's do use the web fetch tool to pull sublayer.com and summarize the site. So it's going to web fetch and hopefully do something.
What's all this turn 1 and turn 3 stuff?
So that's from, I guess it's probably more debugging info. Turn is, user says something and the agent says, or basically a call and response is a turn.
This is baked into VSM?
This is baked into VSM, yeah. Web-based, Ruby-based AI framework. Augmentations AI. So being able to quickly create a chat-based agent, connect some MCP servers, or create your own, create some tools, and then have a scoped agent for whatever you'd like is very quick to get started to experiment with. And I think that's all I had for the demo. But back to what does this mean? Well, I think this means that frameworks become less of things that you learn from like a syntax perspective and an API perspective, and more negotiation protocols. And so, essentially self-documenting systems that both humans and AI can understand, which is what Matt was talking about earlier too. But what this does is it enables communication at a higher level of abstraction than purely code, and the architecture becomes a conversation. And the way I'm looking at it is that today's experiment is tomorrow's training data. So when you're building these, not only do you need to focus on the documentation, but you need to be thinking about what are these concepts? Can you design these concepts for both AI and human comprehension and agentic maintainability? Because I don't see us really writing a lot of code, but in the meantime, we need to be thinking about our internal libraries and our internal code as a Pidgin and as a way that we can kind of talk about concepts roughly with an AI agent because eventually they're going to be Creoles, and we're going to be talking about them natively. Thank you. That's my talk. The gem is available on GitHub if you'd like to look at it, or just gem install VSM. I'm probably going to write something up about this weekend on my newsletter, worksonmymachine.ai. So if you're not a subscriber, check it out. It'll probably be a little redundant, but had some more interesting stuff in there. And I'm Scott Werner on Twitter.